Good day. My name is Al Schwartz, and I am the HD-CCTV product manager for EverFocus Electronics in the USA. Welcome to our presentation on Megapixel over Coax, the basics and the advantages of EverFocus high-definition CCTV. Today we're going to talk about how to apply high-definition megapixel to closed-circuit TV surveillance applications, and to do that we need to consider the concepts of observation versus identification, the ability to zoom with clarity, and a new concept for us, the number of pixels per foot of area viewed. We also need to talk about reality versus what I call the CSI Effect. CSI is a television crime show popular in the US where people frequently do things that are simply not possible with real-world closed-circuit TV systems, such as the illustration you see here, where we started out with a 12-megapixel picture and can get a very, very clear image of the dollar bill, but that is not practical for traditional megapixel cameras in this day and age. How do we deliver megapixel? Originally, the only way to deliver megapixel was through IP. Well, we still deliver megapixel through IP, but now we can also deliver megapixel resolution through high-definition closed-circuit TV, HD-CCTV, over plain old coax, digital signals without networks. The benefits of HD-CCTV we're going to talk about involve reduced total cost of ownership when installing a system, reduced cost of equipment, due to a potentially wider practical area of coverage, and reduced system component costs. Reduced total cost of ownership also comes from the ability to reuse existing infrastructure, the existing wire, coax and power wires, and existing cameras when applying hybrid DVRs that record both high definition and standard definition signals. Reduced total cost of ownership also comes from reduced skill levels required on the part of installation staff and the part of customers. So direct labor costs can be reduced because the level of competence of the technicians who are doing the installation work can be reduced. And there are reduced costs of training, both training of direct staff and training of customers to operate these systems, since HD-CCTV operates the same way as their familiar standard definition embedded DVRs do now. Let's move to the concept of observation versus identification. For general observation, we generally view a wide area. For identification, we typically need a close-up view. For observation, each camera covers many square feet. This requires fewer cameras to cover the area. However, objects will appear small and details will be indistinct. For identification, each camera covers a small area. Objects appear large. Details are well defined. But to cover a large area in this manner may require many cameras, and given that budgets are finite, there may be no coverage of some areas. What if we zoom? We can always zoom, but we may not achieve clarity after we zoom. This depends entirely on the original image detail. That brings us to pixels and megas, as in megapixels. A pixel is a picture element. Pixels are digital, non-analog. They may be round or square, but digital pictures are composed of dots in a grid pattern. The more dots, the more pixels, the better the clarity. Please note in this example that to fully represent the letter R and have it be clear requires 10,000 pixels. The picture to the left of the 10,000 pixel image, the 2,500 pixel image, as you can see, is indistinct. So allocating 2,500 pixels, just 50 by 50, to merely the letter R does not yield a crisp, clear image. Please keep this in mind as we talk about the number of pixels allocated to an entire scene. What is HD megapixel? Just so we're all applying the same definitions to terms, when I say 1080 HD, I am talking about an image that is 1920 pixels across, 1080 pixels high. That works out to be a total of 2 million and change in pixels, and I tend to call that 2.1 megapixels. 720 HD is an image that's 1280 pixels across, 720 pixels high. That works out to be 921,000 and some pixels, and I tend to call that 1 megapixel. For reference, standard definition or analog video is 740 pixels across by 480 pixels high. So that means that we're at 345,000 and some pixels, about a third of a megapixel. Now remember that H.264, when recording analog video, only records 704 pixels by 480 pixels, but still 337,000 pixels, nominally 1/3 of a megapixel for traditional analog video, at least for NTSC. PAL has a few more pixels. So let's do a reality check. Let's look at the mathematics of zooming. Here is an image that is 1920 by 1080 pixels. This is 2 megapixel HD. And let's examine this individual that we can see in this scene. If we look at 2x zoom, and we start with our 1920 by 1080 picture, when we go to 2x zoom, we're expanding an area to be twice the width, twice the height, essentially 4 times the area. Only 1/4 of the image will be in view at a time, and that 1/4 of the image will then be expanded to full screen. So if we take our base image, we are expanding the 1920 by 1080 image, and we're ending up viewing an image that is only 960 by 540. And that's your 2x zoom. We can see the individual, and this is what it looks like full screen, but we're down to 960 by 540 resolution, which is only slightly better than SD. At 4x zoom, since this is geometric, we are viewing only 1/16 of the image. So if we start with our 2x zoom image, 960 by 540, take just 1/4 of that image, blow that up to examine it, we're now down to 480 by 270 pixels. Taking the base image, looking at just this tiny area, blowing that tiny area up full screen, and this is our 4x zoom image starting from a 1080 HD image. At 8x zoom, we're looking at 1/64 of the image. We're going to take our 4x zoom image, take 1/4 of that image, blow that up to be full screen. We're down to 240 by 135 pixels at 8x zoom, even starting from 2 megapixels. So we'll take our 1920 by 1080 base image. At 8x zoom, we're taking just this tiny area, expanding it to full screen, and that's what a 1080 image looks like at 8x zoom, 240 by 135 pixels. If we go to 16x, we're looking at 1/256th of the screen. We take our 8x image, take 1/4 of that image, blow that up full screen. We're down to 120 by 68. Not a lot of pixels for the entire image. Not even as many pixels as it took to render the letter R. And there you have a 16x full screen image of the gentleman that we were viewing from the original image. It's only 120 by 68. No, you don't need glasses. It's blurry because that is all the pixels that there are to represent this image. If we start from 720 HD, starting at 1280 by 720 pixels, looking at the same individual, here is a 2x picture, 640 by 360. We're already below SD. At 4x, we're at 320 by 180. At 8x, we're down to 160 by 90. And what did we do before we had HD? We started out with a 720 by 480 image. At 2x, we're down to 360 by 240. At 4x, we're down to 180 by 120. And at 8x, we're down to 90 by 60. Far fewer pixels than was necessary to render the letter R, trying to spread those across an entire scene to make out the features on an individual. Not going to happen. If we compare the 4x zoom images between 1080, 720, and standard def, we can see immediately the reduction in clarity because of the lack of pixel resolution in the lower resolution images, and it's even more apparent when we compare them at 8x. Again, we need to beware of the CSI effect. I'm not sure what shows are popular around the world, but people will watch television, they will watch crime shows, they will start out with an image like this and turn it into an image looking like this. Now, you can do this if you substitute an unlikely picture. Please note that the image represented on the right-hand side of the screen started out as a 17 megapixel image. Imagine what the cost would be and the bandwidth requirements if every camera in the system was a 17 megapixel camera. But that's what it takes to get this kind of clarity on zoom, to start with 17 megapixels and not 2. That brings us to clarity planning. If we want clear pictures on zoom, we need to do clarity planning, and that's always been an issue, but now it has a new dimension. More pixels gives us better clarity, but how many pixels is enough? Originally, the number of pixels was fixed. Everything was in standard definition, 720 by 480, a third of a megapixel. That's all we had to apply. We only had a single variable to use, the field of view. We could control the viewing angle and the distance from the camera to the area of interest, but that was our only variable. Now we have a new variable, pixels per foot, because we can not only choose the field of view, we can choose the number of pixels. It's a new concept. We control the viewing angle and distance. We control the field of view. Plus, we can now choose the number of pixels and deal with the number of pixels divided by the viewing width. This gives us pixels per foot. How many pixels are enough? In a close-up view, objects are larger. Larger objects intersect more pixels. In a wider view, spreads out the pixels. There are fewer pixels allocated to each object. We would prefer more pixels to get better resolution. Now, here are some typical pixel per foot targets. These images are courtesy of the engineering people at Thea Technologies. They make wide-angle megapixel lenses, and I thought that the information was relevant, and they agreed to allow me to present this as part of this instructional material. Their suggestion is that for overview of an area, 10 pixels per foot or 30 pixels per meter is satisfactory. To do detection, for general security applications, they recommend 20 pixels per foot or 70 pixels per meter. If you want to be able to recognize an individual, they suggest you need 40 pixels per foot, and they distinguish between recognition and identification, the ability to convince a stranger that you are showing a particular individual, and that brings us up to 60 pixels per foot or 200 pixels per meter. And here's a comparison of 10, 20, 40, and 60 pixels per foot. When you're thinking about how many pixels you can get in a scene, remember that the 1920 pixels from 1080 HD divided by the 720 pixels of standard definition is a 2.7 to 1 advantage. So if you go to 2.7 times the field of view, then you will be back to standard def. If you go wider than 2.7 times, then you are going to reduce the number of pixels below standard definition levels. So looking at our original image, this scales out to about 100 feet wide, which means that in a 1080 image, you're at 19 pixels per foot. In a 720 image, down to 13 pixels per foot. And in a standard def camera, down below 9 pixels per foot. So again, here's our comparison at 8x zoom between 19, 13, and 8.6 pixels per foot, 2 megapixels, 1 megapixel, and standard def at 1/3 of a megapixel. So let's look at the benefits of HD-CCTV megapixel. We can cover the same area with better resolution, an increased number of pixels per foot, the ability to zoom with more clarity, to use for recognition and identification. Alternatively, we can cover a larger area, the same number of pixels per foot as standard definition, to use for overview and detection, and in this case we need fewer cameras and DVR ports to cover the same area. Or a trade-off can be selected in between. How do we use this? How do you connect HD? HDMI cables don't work. They're too short, too expensive, it's too complex. We need a transport system for professional closed-circuit TV surveillance that will cover hundreds of feet, that is economical and practical. The way we connect HD-CCTV, the way we transport it, is on wire, but we use Coax, or we can use fiber, but we don't use HDMI. We're transporting serial digital data at high speed to provide real-time video. And we're doing it over traditional coax with BNC connectors. HD-CCTV is based on the high-definition serial digital interface, HD-SDI. It transmits 1.5 gigabits per second per channel. That's correct. More bandwidth than your typical fast Ethernet connection on each channel going back to the DVR. It's high speed to carry the data, digital for noise immunity, and it's designed for longer distances over plain old coax using BNC connectors. HD-CCTV transport will carry 1 and 2 megapixel HD, 720 or 1080, at 1.5 gigabits per second per camera. That means that an 8-camera DVR is processing 24 gigabits per second of digital data over RG59 coax and BNC connectors. You can go longer distances with RG11 or RG6 cable. There's no networking or IP addressing required for the transport of the video from the cameras back to the DVR, only for remote viewing of the DVR, so no modems or routers or ports are required to connect the cameras back to the DVR. Now, coax type and quality matters. It's never really been about distance between the camera and the viewing device. It's always been about signal loss. It becomes more apparent in HD-CCTV than it was in SD. What matters is the cable specification in decibels loss, dB loss per 100 feet. And for HD-CCTV, typically the spec we want is the measurement at 750 megahertz or 1 gigahertz for HD. We want to keep that total loss, decibels per foot times length in feet, or decibels per meter times length in meters, under about 36 dB net if you're measuring it at 750 megahertz, under about 42 dB net if you're measuring at a gigahertz. We can reach up to nominally 500 feet on typical good quality RG59. Not special RG59, but good quality RG59, solid copper 20 gauge center conductor, 95% copper braid, foam dielectric, reasonable price, good quality RG59 will go about 500 feet for HD-CCTV. So how does HD-CCTV connect? home run RG59 coax using BNC connectors. Does that sound familiar? Let's compare what's inside a standard def camera with an HD camera. A standard camera that we're used to all these years has a standard lens, a standard sensor, does some signal processing, has a video modulator, and out of the BNC comes a standard analog video signal, whether it be NTSC or PAL or CCAM. And a megapixel camera will have a megapixel lens, a megapixel sensor, some signal processing, and then an HD-SDI modulator, and coming out of the BNC is HD video as a serial digital signal. So the topology of an HD-CCTV system looks like this, which I think you will find is exactly similar to the topology of any analog system that you've installed. I'd like to talk a bit about EverFocus HD-CCTV product offering, the hardware that we have to allow you to deploy systems which will give you this kind of performance and these advantages and benefits. To deliver HD-CCTV, you need cameras, lenses, recorders, displays, and accessories. We have cameras that are dual resolution. Our EQ5200 box type camera is in stock. Our EHH5200 outdoor dome and EDH5240 indoor IR dome will be available in a few weeks. These cameras allow you to field select your resolution, either 1080 or 720, and these are all dual voltage cameras, 12 volts DC or 24 volts AC. We also have cameras that are 1 megapixel, 720 only. We have in stock at this time EQH5000 box type camera, the EHH5040 IR outdoor dome, the EZH5040 IR outdoor inline bullet. The dome and bullet are dual voltage. The box camera is 12 volts DC only. So again, to recap, the EQH5200 dual voltage, choose your resolution in the field. Use a 2 megapixel sensor, has 0.02 lux sensitivity. This is a true day-night camera, supports DC iris lenses, and all EverFocus HD CCTV cameras have a mode where they produce a standard definition output signal for test purposes, so you can still aim and focus your cameras with your standard handheld analog test monitor. It is not necessary to carry an HDMI monitor or a PC up a ladder to aim and focus these cameras. In terms of megapixel lenses for the EQH5200, we have 2 in stock so far, 4.5 to 10 for wide views and an 8 to 80 for long shots. These are half-inch lenses to fit the large sensor in the camera. And again, in terms of box cameras that will also use these lenses, we have the EQH5000. This is a 1 megapixel 720 camera, 1 lux sensitivity. Also true day-night, 12 volts DC only. Also has the standard def test output and supports DC iris lenses. Coming soon is our 3.3 to 12 millimeter varifocal auto iris megapixel outdoor dome with 3-axis mounting. It is an IP66 vandal resistant dome, dual voltage, dual resolution, 2 megapixel sensor, 0.5 lux sensitivity, true day night, and also has the standard def test output. The EDH5240 also has a 3.3 to 12 varifocal auto iris lens. It is a 3-axis housing that can be surface or flush mounted with the same housing. Discard the back can and you can mount the camera flush with the surface. It's a dual voltage camera, choice of resolution in the field, 2 megapixel sensor. Because of the 34 IR LEDs, it has a 65-foot IR range and requires 0 lux when the IRs are on. Again, it's a true day-night and has the standard def test output. The EHH5040 is in stock, has a 3 to 9 millimeter megapixel lens. This is a 1 megapixel 720 camera. 100-foot range at 0 lux with the 30 IR LEDs, true day-night, dual voltage, vandal resistant IP66, and with the same standard definition test output. The EZH5040 inline IR bullet, 3 to 9 millimeter varifocal megapixel lens, 1 megapixel resolution, 45 IR LEDs, 150-foot range without external illumination, true day-night, dual voltage, test video output in standard definition, and this is IP67 rated. For a recording solution, in stock today, we have the EP-HD-08, which is 100% HD. We also have cameras that allow you to mix hybrid DVRs that mix high definition and standard definition analog, whether it be the EDR HD 2H14, 2 HD cameras with 14 SD cameras, or the EDR HD 4H4, 4 HD cameras and 4 SD cameras. The EPA HD-08 can record in full 1080 at 15 pictures per second per camera on all 8 cameras, or can record in 720 resolution at 30 pictures per camera on all cameras. This particular DVR, the settings are global, so it can use either 720 cameras or 1080 cameras on all ports. It has 2 main monitor outputs, both HDMI and VGA outputs. They show identical images, and the image comes out at 1920 by 1080. It looks like a DVR, it installs like a DVR, but it's HD. These DVRs use H.264 compression. The EP-HD-08 comes configured with a minimum of 4 terabytes in the US, with a maximum of 8 terabytes inside the DVR. It also supports our EDA450 eSATA expansion module, which can be used to add another 8 terabytes of storage for a total of 16, and the DVD is built in. There are 3 USB ports. There are alarm inputs per camera, audio inputs per camera, with 2 Form C alarm outputs, 1 audio out. Has our standard web graphical interface, including the ability to zoom over the web interface up to 16 times. It supports mobile viewing with multiple web browsers and our EverFocus PDA application that works with iPhone, Android, BlackBerry, and I'm sure eventually will support the Symbian operating system. And there is an HD player that allows you to play back the recorded video, and that can be copied when the video is downloaded. Our hybrid DVRs are used where not every view requires HD. The ports are dedicated to format. That is, an HD port must have an HD camera attached, an SD port must have an SD camera attached. The state of the technology is not such yet that we can switch back and forth on a per port basis between HD and SD. So you can use HD where required in the application, and you can cover other areas with existing standard def cameras when doing an upgrade, or with new lower cost standard def cameras, as long as it gives you the number of pixels per foot that you need for that field of view. So with hybrid DVRs, you can upgrade just part of an existing system, or you can install new systems with selective HD. You can mix and match HD resolutions on a per port basis. That is, you can have 1080 cameras on some of the HD ports and 720 cameras on other HD ports, mix and match, so you can have 3 different resolutions on the same hybrid DVR. The SD cameras have looping ports, as you would expect from a typical high-end DVR. So here are some images of our hybrid DVRs. We have the Endeavor HD 2H14, 2 HD cameras plus 14 standard def cameras if you just want to dip your toe in HD-CCTV. If you want to fully get your feet wet, the Endeavor HD 4H4 offers 4 HD cameras plus 4 standard def cameras. These hybrids record real-time or up to real-time at D1 on all the standard definition ports, and the standard definition ports loop out. On the HD ports, you have your choice to record 1080 at 15 pictures per second or 720 at 30 pictures per second. You can have up to 4 hard drives internal, which means you can run these up to 8 terabytes. You can add our eSATA external EDA450 array and add another 8 terabytes for a max of 16. DVD burner is built in. There's audio per channel, alarm input per channel, compatibility with our mobile focus app, and uses the same HD player to play back recorded video that you copy off the DVR. This is a point where we can break out to a demonstration and look at actual performance from an HD DVR. It's important when considering an HD system to choose the right monitor. For best results, please use a high-quality EverFocus high-def monitor. If you use a monitor that is not capable of displaying all of the resolution that an HD system is capable of delivering in live and playback, then you will lose some of the effect of the HD system. Again, we have VGA and HDMI simultaneous images, so if you're using a VGA monitor, make sure it has a full 1920 by 1080 capability. If it's an HDMI, make sure it is a full 1080 resolution monitor. But still, not all 1080 monitors are created equal. The internal workings, the scaler within two different 1080 displays may provide a sharper picture on one than the other. So if you consider our EN 1080p 22, 24, 32, 42, and 55-inch monitors, I think I can say without fear of contradiction that while you may find other monitors with images that compare favorably, you will never find one that has an image that is better. I'd like to talk a little bit about HDcctv accessories, repeaters and extenders, converters, splitters, and fiber transmit and receive sets. We offer the EHA-SRX, which takes a single HD-CCTV input. Now, the beauty of this, because it's digital, it repeats and reprocesses. So long as the signal is above the noise threshold, the pulse train is reconstructed, and the pulse train coming out of the repeater is absolutely identical to the original pulse train transmitted by the device up the line, which means, in theory, effectively, you can repeat these indefinitely without loss of signal, unlike an analog situation where eventually, because of signal-to-noise ratio, the image will become degraded. The EHA-SRX has a single HD-CCTV output on BNC, but it also produces a single HDMI output. We have the EHA-RPT, which accepts a single HD-CCTV input, repeats and reprocesses, and produces the same signal on two HD-CCTV outputs. For applications, suppose you want a public view monitor. I'm not quite sure how public view monitors get accomplished all the time on IP systems. I suppose if there's a decoder available, it makes it more convenient. Otherwise, you have to stash a PC somewhere. In this case, you would take an HD camera, connect a piece of coax to an EHA-SRX, take the HDMI output from the EHA-SRX to your public view monitor, and get a full HD image for public view. Take the coax output from the EHA-SRX and just bring it back to the DVR. For longer runs, you can use an EHA-RPT to boost the signal and provide you with a crisp, clear, original signal, digital signal out to continue your run back to the DVR. However, if you use an EHA-SRX for your repeater, you not only get the signal repeated, but it offers you the HDMI port as a temporary test monitor port to confirm that you have good signal to that point. For HD-CCTV, if you want to handle looping, bring the video back to the DVR, install an EHA-RPT between the camera and the DVR, take one output of the EHA-RPT to the DVR for recording, take the other output over coax to an EHA-SRX, which will then decode to HDMI and can be used to produce a spot monitor. So both the EHA-SRX and the EHA-RPT repeat and extend the HD-CCTV digital signal, creating a signal which is identical to the original signal. The EHA-SRX also provides the HDMI output, which can be a repeater with a test point for a public view monitor or spot monitor. The EHA-RPT produces two HD-CCTV outputs to repeat and split, or just to split. To go over long distances, instead of putting multiple repeaters, it's more convenient to go with fiber media converter sets. Our sets today take a single video stream using a common chassis, and small format pluggable multi-mode or single-mode transmit and receive modules can offer you a multi-mode range from 1,600 feet to a single-mode range of 13 miles. Our fiber sets include the transmit and receive chassis and the fiber transmit and receive modules that fit into the chassis. We have the EHF 1M500M, multi-mode signal, one video 500 meters, and the EHF 1S21K, a single mode set that will go 21 kilometers. And again, fiber is never really about distance, it's really about dB loss budget, which has always been apparent in fiber and now becomes more apparent in coax as we deal with HD-CCTV. So to recap the benefits of HD-CCTV, reduced total cost of ownership because of reduced equipment cost, resulting from a wider practical area of coverage or lower system component costs. Reduced total cost of ownership because of the ability to effectively and practically reuse existing infrastructure, reusing wire and connectors, reusing cameras when deploying a hybrid system, combining existing standard def cameras with new high def cameras to create a system. Reduced total cost of ownership because of the reduced skill level that's required on the part of customers and installation staff. Lower direct labor costs because of the lower skill level required on the part of the technicians, and reduced training costs for staff and for customers because HD-CCTV systems are as easy to operate as the systems that people are operating now for standard definition. HD-CCTV provides megapixel resolution in a manner that's easy, familiar, cost-effective, applicable today and tomorrow. Thank you for your time, and EverFocus appreciates your business.